All right, so I mentioned yesterday that if you are able to convert a complex number into polar form, it can actually make performing operations between complex numbers a little bit easier, okay? So today we're just going to look at the operations of multiplication and division between complex numbers, all right? You've done this a little bit already in rectangular form in this course, but also back into like your Algebra 2 course. You just never have done it from the polar standpoint, okay? So I'm working with two complex numbers in polar form, z sub 1 and z sub 2. Z sub 1 equals r sub 1 multiplied by cosine of theta sub 1 plus I sine of theta sub 1. And then you can see z sub 2 follows a similar format. If I would like to find the product between those two complex numbers, when they're in their polar form, all I need to do is multiply their two moduli together, r sub 1 and r sub 2. Moduli is just the plural of modulus. So multiply r sub 1 times r sub 2. That'll give me the modulus of the new complex number. And then notice the other thing I have to do is add their angle measures together to give me the argument of cosine and sine in my product. Okay. Similarly, if I want to find the quotient between these two complex numbers, so if I'm taking z sub 1 divided by z sub 2, I'm going to take the r value from z sub 1 divided by the r value from z sub 2. That's going to give me the new modulus of the quotient. And then notice I will also subtract the angle measures, theta sub 1 minus theta sub 2, to give me the argument of cosine and sine in the new quotient. Okay, so let's apply those, think of those as formulas here to this example. Here I have z equals 3 times cosine of 20 plus I sine of 20 degrees, w as 5 times cosine 100 plus I sine of 100. Notice I want to express my product and my quotient so that the angle theta is between 0 and 360 degrees. Okay, so product ZW, that's just going to be equivalent to the modulus from Z multiplied by the modulus from W times the quantity of the cosine of 20 degrees plus 100 degrees plus I times the sine of 20 degrees plus 100 degrees. And then I just simplify. That's going to give me 15 multiplied by the quantity of cosine 120 degrees plus I times sine of 120 degrees. Okay, so that would be the polar form for the product. And then, of course, you could convert that into rectangular form if you just found cosine of 120, sine of 120, and multiplied each of those by 15. Okay. All right, now if I want to find the quotient between those, let me give myself a little more room here. I'm going to move this down a little. Okay, so very similar. I'm just going to take the modulus from z, which is 3, and now divide it by the modulus from w, which is 5. And that 3/5 will now multiply the cosine of my first angle measure, 20 degrees, minus my second angle measure of 100 degrees. Order is important here. Notice I'm taking the angle from z subtracted by the angle from w, since my quotient is z divided by w. Okay, then I'll just add on I times the sine of 20 minus 100. Okay, now cleaning this up, that gives me 3/5 times cosine of negative 80 degrees plus I times the sine of negative 80 degrees. And some of you are going to be tempted to leave that as is, but then you would be violating the rule that theta is supposed to be between 0 and 360, right? So I need to get a coterminal angle to this negative 80 degrees here. Just add 360 to it, and now we can rewrite this as cosine of 280 plus I sine of 280. Okay, there would be the polar form of my quotient between those two complex numbers. All right, let's extend this. Okay, so now I'm kind of going in the other direction here. I have the two complex numbers z and w in their rectangular form, and I want to find the product of those expressing all three complex numbers in polar form. Okay, so basically what we're being asked here, we're asked to find z times w, so 3 plus I multiplied by 5 minus 4i. You've done that before in the rectangular form. We just want to be able to do it in the complex polar form. Okay, so begin by converting both z and w into their polar form. So I'll start with z. Okay, I need its r value or its modulus. X squared plus y squared equals r squared. That's going to be basically 9 plus 1 equals r squared. R is going to be the square root of 10 here. Okay. And then theta is going to be the inverse tangent of 1, which is my y value, divided by 3, which is my x value. And notice the directions here. It says round all angles to the nearest degree, right? So if I find inverse tangent of 1/3, that's 18.4 degrees. So I'm going to round that just to 18 degrees. Okay? So that means z can now be thought of as the square root of 10 multiplied by cosine of 18 degrees plus I times the sine of 18 degrees. Okay. Now I'll go through and do the same thing for the other complex number of w. So x squared plus y squared equals r squared once again. So that's going to be x squared would be 5 squared or 25. Y squared would be negative 4 squared or 16. Okay. 25 plus 16 is 41. So r is going to be radical 41 here. Okay. Theta is going to equal inverse tangent of negative 4/5. Okay, now think about that. The point 5, negative 4, that is in the fourth quadrant, right? That is in the fourth quadrant. And when I do inverse tangent of a negative measure, it does give me a fourth quadrant angle. It's just going to be expressed in the negative direction. So I'm going to need to add 360 to it to get it expressed in the positive direction, to be between 0 and 360. Okay, so let me punch that in. Inverse tangent of negative 4/5 is negative 38.7 degrees approximately. So if we add 360 to that, we're looking at 321 degrees approximately. Okay, so now w can be thought of as the square root of 41 multiplied by cosine of 321 degrees plus I times the sine of 321 degrees. Okay. All right, so most of the work's done. Now that I've got both of those in polar form, I can find their product using the formula from our previous slide, right? This formula right here. Okay. So z multiplied by w, I'll take my two r values, my two moduli, multiply those together. And then that is going to have to multiply the quantity of cosine of 18 degrees plus 321 degrees added with I times the sine of 18 degrees plus 321 degrees. Okay, so square root of 10 times the square root of 41. That's just the square root of 410. Okay, and then 321, if I add that with 18, I end up with cosine of 339 degrees plus I times the sine of 339 degrees. Okay. That is my resulting product.